Hey guys, so now that we've looked at exponential and logarithmic functions, now we're going to look at more the algebraic part of everything. So we're going to look at properties of logarithms, and then we're going to solve some exponential and logarithmic equations. So first of all, the first property that we're going to learn is pretty important. So when you have log base b of a to the x power, we can go ahead and take this x and bring it out front. So that way I don't have it as an exponent anymore. It's kind of on the same level as everything else. So I can bring this x out front and have it as x times the log base b of a. So that one is really helpful. Remember, my exponent can come out front, so that way it's no longer an exponent and I don't have to deal with it in the same way. So that's really helpful. The next few rules that we have, what can be helpful is to think about those exponent rules that we talked about at the beginning of the unit. So with our exponent rules, if you remember, when we multiply the bases, we would add the exponents, right? So now that we're talking about logarithms, if I have log base b of a times c, since a and c are being multiplied, we can go back and think about, well, what did we have to do with the exponents? We added them, right, when we were multiplying our bases. So when I break this up into two different logs, I can write it as log base b of a plus log base b of c. So since a and c were being multiplied, I add their logs together. Okay, down here on this guy, so remember, for exponent rules, when we were dividing our bases, we had to subtract our exponents, right? So now that we apply that to logs, if we have log base b of a divided by c, well, since they're being divided, then I will subtract my logs. So important thing to know, ln, if you see that, that's for natural log. The natural log is the inverse of the natural base. So important things to know and to note for the future, especially when you're trying to solve equations. The natural log of e to the x. Natural log and e cancel each other out, so we're just left with x. Same idea with e to the natural log of x power. E and natural log cancel each other out, so we're just left with x. So those are inverse operations, so they undo each other. That will be helpful to know. So what we're going to do first is we're going to take all of these properties and try expanding them and compressing them to rewrite the logs. So in our first example, we want to expand log base 4 of u over v to the 5th power. So when we start to expand this, we want to use log base 4 for everything. Nothing is going to happen to that base. He just kind of gets carried along, just like the base in our exponent rules. So we want to kind of go, work our way from the outside in. So I have this to the 5th power, right? So that exponent can be brought out front. So that way everything is on the same level. Bonnie, quit itching. Hey. Come here. So we've got 5 log base 4 of u over v. So now that I have u divided by v there, I have to think of, okay, so if I'm dividing those guys, what do I have to do with my logs? When I'm dividing, that means I have to subtract. So I am going to have 5, and oopsies, that's a weird looking 5. And since u over v, that entire thing was taken to the 5th power, I need to make sure that I have parentheses around when I subtract these two logs, so that way the 5 gets applied to both of them. So I need to make sure that I have parentheses with log base 4 of u. And then like we said a second ago, since they're dividing, I'm going to subtract my logs. Log base 4 of v. Okay, so there's that guy expanded. Now let's go ahead and look at b. So we have log base 2 of 3 times 2 cubed. So first of all, if you notice, this cubed only goes to that 2, so I'm going to deal with that cubed a little bit later. The first thing I'm going to do is deal with these two guys right here. So 2 and 3 are being multiplied. Since they're being multiplied, that means I have to add those two logs together. So I have log base 2 of 3 times log base 2 of 2 thirds. I'm sorry, I just said times. No, since I'm multiplying, I have to add my exponents. That should be a plus right there. I'm sorry, guys, my mistake. Now over on this guy, I still have my cubed on my log base 2 of 2 cubed. So I'm going to bring that 3 out in front to that log. Don't bring it all the way out front over here. Bring it in front of its own log. So now we'll have log base 2 of 3 plus 3 log base 2 of 2. So we could stop there, but I wanted to have a conversation with you real quick about what is log base 2 of 2. So remember, if we were to write this in exponential form, this would be saying 2 to what power is 2? Well, 2 to the first power is 2, right? So log base 2 of 2 is just 1. So another way to rewrite this is log base 2 of 3 plus 3. Remember, technically, that's times 1 right there. So you can write it as just plus 3. You can ignore it altogether, but I just wanted to make sure that you knew you could go on and keep simplifying it. So now that we've expanded those, we're going to go through and contract them now, or not contract, compress them. So this can be really helpful when you have big equations that are big and spread out and you had a lot going on. You can condense it all down into one log and it's a little bit easier to deal with. So right here we're going to compress 4 log base 7 of x plus 4 log base 7 of y. So what we can do, these 4s before they came out front, they used to be exponents. So I'm going to pop them back up onto my bases right there. So I'm going to have log base 7 of x to the 4th minus log base 7 of y to the 4th. So I'm subtracting these two logs. If I'm going to subtract those logs, and then if I'm subtracting 2 logs and I want to compress them into 1 log, subtracting means I divide those inside guys. So I'm going to have log base 7 of x to the 4th over y to the 4th. You can absolutely keep it like that. One thing that to me it's kind of screaming, hey, factor out that 1/4 power, or I'm sorry, the 4th power. You definitely don't have to. But I'm going to rewrite this as log base 7 of x over y to the 4th power. Okay, over here we have the natural log of u plus 6 natural log of v. So as we saw a second ago, this coefficient used to be an exponent, so I'm going to take that back up to be an exponent there on v. So I have the natural log of u plus the natural log of v to the sixth. Okay, so I'm adding those two logs together. So when I condense them into one log, since I'm adding, that means I need to multiply u and v to the sixth. So I'm going to have natural log of u times v to the sixth. Okay, so these things aren't that difficult. It just takes a little bit of practice to remember all the different rules. As of right now, like, why are we actually doing this? A lot of pre-calculus is not a, hey, we're going to be expanding and compressing logs in your everyday life. That's not going to happen. We're doing math to do more math at this point. So when I tell you, why do you really need to know this? Because when you get into calculus and you need to simplify equations and solve different equations, expanding and condensing logs is going to make your life a lot easier. If you can break it up into pieces, that might make the problem easier. If you can squish it all together, that might make the problem easier. So being able to rework them is really helpful for when you get into calculus. So. Okay, let's solve some problems. So the first one we have is we have 16 to the 3x plus 3 power, and 64 is to the negative 2x minus 2 power, and those two things are equal. So what does x have to be for those two expressions to be equal to each other? So the first thing that I want you to notice or really look at are 16 and 64. What do 16 and 64 both have in common? 16 and 64 are both powers of 4. And they're also powers of 2, but I'm just going to approach it from the power of 4 way this time. You could also approach it as a power of 2. So we know that 16 is 4 squared, right? So I'm going to write 16 as 4 squared. And then in parentheses, I'm going to put that power that I had just a minute ago, that 3x plus 3. Equals. Okay. And then 64 is 4 cubed. So I'm going to rewrite 64, oopsies, that's what we were looking for, as 4 cubed. And in parentheses, I'm going to put that exponent that I had before. Negative 2x minus 2. So now that our two bases are the same, and these two expressions are equal, that means that the two exponents have to be equal to each other. So that means that 2 times 3x plus 3 is equal to 3 times negative 2x minus 2. And now we'll go through and solve. So we're going to go ahead and distribute through that 2. So we'll get 6x plus 6 equals. And then we'll distribute through that 3 and get negative 6x minus 6. And then we'll solve. I'm going to add the negative 6x to this side to get 12x. I'm going to subtract that 6 to the other side to get negative 12. Add by 12, or I'm sorry, divide by 12 and get negative 1. Okay. In this next one, it says that 5 to the negative 3b power equals 1 over 25. So here's a few things that you might be thinking. Okay, cool. I know that 5 squared is 25. Wonderful. How do we get that 25 to the bottom? If that exponent is negative, that's what gets me to the bottom, right? So here's what we're going to have to do. I know that this guy right here, that exponent has to be negative 2, right? Because 5 to the negative second power gives me 1 over 25, right? So I know that my exponent is supposed to be negative 2, so that means I'm going to set whatever this exponent is equal to negative 2. So I have negative 3b equals negative 2. We'll divide by negative 3 on both sides to get b by itself, so b will be equal to 2/3. Okay, let's keep on keeping on. Now we have log base 11 of 5x minus 9 is equal to log base 11 of 4x plus 4. So if we notice, we have the log base 11 on both sides, so that must mean that the insides are equal to each other. Another way of thinking about it is that log base 11 is made to undo something to the 11th power. So to undo a log base 11 is I can take both 11 to each side as a power. So 11 to the log base 11 of the 5x minus 9 power and 11 to the log base 11 4x plus 4 power. What's going to happen with my 11 to the power of log base 11? Those just cancel out. So then we're just left with 5x minus 9 equals 4x plus 4. Okay, so now we'll start to solve. Subtract 4x and add 9. So x will equal 13. So in D is one of those examples of when expanding and condensing logs can make solving problems a little bit easier. So we have the log of 2x minus the log of 4 equals 1. So I'm going to go ahead and put those into one log to make my job a little bit easier. So since I'm subtracting those logs, I'm going to divide the stuff that they have on the inside. So I'm going to write this as the log of, and then 2x goes on top, 4 goes on the bottom, and that's equal to 1. So remember, when no base is written there, that means that it's the common log. The common log means that the base is 10. So to get rid of this log, I'm going to take 10 to both sides power, or both sides as a power. So when I have 10 to the log of 2x over 4 power, 10 and log base 10 cancel each other out. So I just have 2x over 4. And then over here, 10 to the first power is 10. So then we'll solve, multiply by 4 on both sides. So 2x equals 40. Divide by 2, so x equals 20. Okay. So now we have 16, oops, I really just need to turn off the screensaver. Okay, so right here we have 16 to the x power minus 9 equals 49. So we're going to start working our way into the x just like we did before. So I'm going to add 9 on both sides. So now I have 16 to the x power equals 58. All right. Now, what you might be thinking of doing right here is, okay, so I know that to get rid of a base 16 is to take a log base 16 and all that sort of stuff, and you can absolutely feel free to do that. I know that on the newer calculators, let me grab mine. With these, you can go through and input the base on these, but you're not always able to do that. And if you have a calculator that you can't input the base on there, you're kind of stuck, and then you have to remember a change of base formula. And that's just not how I solve these types of problems. And I would like to teach you the way that I solve these types of problems, and I hope you like it. If you're not a fan and you want to approach it another way, that's totally fine. So please don't think that my way of solving these is the end-all be-all. Also, please don't think that yours is wrong because it's done in a different way or our answers look a little bit different. Mine just is all in either natural logs or log base 10 because that's easier to put into my calculator. And so that's just a habit for me. Here we go. Okay, so whenever I have an exponent, I use that first rule that we talked about today. Remember how we learned that when we have an exponent and we have a log out front, that means that we can move that exponent out front, and then it's all on the same level and it's no longer an exponent anymore, right? So I'm going to use that. That property is really important. So what I'm going to do is I'm going to take the log of both sides. I'm going to take the common log. You could take the natural log. You could take log base 92. You can take whatever log you want to as long as you stay consistent. The reason I used log and natural log, like I said before, was just because it's what's on my calculator and easily accessible. So what I'm going to do from here is I am going to take the log of both sides. I'm going to take the log of this side and the log of this side. So that means that right now I have the log of 16 to the x power equals the log of 58. So that property that we learned before said that that exponent x gets to be brought out and now be a coefficient. So now we have x times the log of 16 equals the log of 58. So, what did I just say? X is times the log of 16, right? So how do I undo multiplication? Division. I'm going to divide by the log of 16 on both sides. So now I have that x equals the log of 58 divided by the log of 16. So one thing I want to be really, really clear about is that log and 58 and log and 16 are not being multiplied by each other. Log is kind of an operator of that guy. So my logs can't just cancel out. This is not 58 over 16. Let me be very, very clear. This is not 58 over 16. The logs don't cancel out, okay? That's not how they undo each other. Remember, to undo a log, we have to take it to a power, right? So division won't cancel them out. what we have to do is just put that into our calculator to find out what x is equal to. Now, a lot of times on problems where it has anything to do with logs, because most of your answers are disgusting, they'll ask for an exact value, so that way they know you didn't just pop it into your calculator. So this right here, that log of 58 divided by the log of 16, that would be your exact value. But if you put that into your calculator, let me check right here, that would end up being, x is about 1.46. So that's the approximate value. Approximate value would be nice to have when we start solving like word problems with things, so that way it's something a little bit easier to plug in. It's also something we can store on our calculator, and you can just kind of pop this on your piece of paper so that way you know about what's going in there. Okay, let's attack f now. So let's work our way in to x. So we need to get that 4 to the other side. So I'm going to add 4 to both sides. So we end up with 4 to the x plus 6 power equals 38 when I add that 4 on over. And this time I'll take the natural log of both sides. It doesn't matter what kind of log you take. Like I mentioned earlier, sometimes people like to take the natural log of both sides because ln is less letters than log. So whatever floats your boat. So right now we've got the natural log of 4 to the x plus 6 power equals the natural log of 38. So that, go get your bone. So we know that our exponent right here, since I had that log, my property says I can bring it out front. So now I have that x plus 6. I'm going to keep it in parentheses just to keep myself organized, times that natural log of 4. So that x plus 6 gets brought out front to be multiplied by the natural log of 4. And then that's equal to the natural log of 38. So to start working my way into x, it might be tempting to distribute that natural log of 4, but I hope that you wouldn't, because it's going to make your problem just the tiniest bit messier. It's not terrible, but I wouldn't do it. Since x plus 6 and natural log of 4 are being multiplied, I can just go ahead and divide by the natural log of 4 at this point. So that's what I'll do. So I'll just end up with x plus 6 on my left side. And on my right side, we'll have the natural log of 38 divided by the natural log of 4. So the next thing to do to get x by itself, if this side scares you, just to cover it up, well, we subtract 6, just like we did ever since Algebra 1, or even pre-algebra. So that means that x equals the natural log of 38 divided by the natural log of 4 minus 6. So like we talked about earlier, our natural logs will not cancel out because remember, e undoes a natural log. So these will stay like this. This is my exact value right here. If I needed an approximate value and I popped it in my calculator, I got negative 3.38, just in case you're making sure you're getting the same amount as I am. Okay, 2 more and we are out of here. So now we have the natural log of 2x plus the natural log of 8 equals 4. So what we want to do is, since we have those 2 natural logs, is condense them into 1 natural log. So since those natural logs are being added, that means I'm going to have to multiply what's on the inside. So I'm going to have to take 2x times 8 on the inside over there equals 4. So, of course, 2x times 8 is just 16x. I split that up into steps just so you could see what's going on. Okay, now to get rid of a natural log, we need to use our natural base. So what I'll do is e will be taken to the power of each side. So e and natural log cancel each other out. So we'll just have 16x over on the left side, and then e to the fourth is just e to the fourth. We'll keep it like that. And then the last thing we have to do to get x by itself is to divide by 16. So x equals, ooh, silly x. X equals e to the fourth over 16. So that's my exact value. If you wanted to pop it into your calculator to get an approximate value, that would be, oh, I didn't put it into my calculator. Oh, well, don't worry about it. It's fine. You're almost always asked for the exact value, but Okay, over on this next one, we need to work our way into finding x. So we have 3 times e to the negative 6x power equals 90. So let's start working our way in, and let's get rid of that 3 over on the left side. So since 3 is multiplying e, we need to divide by 3 on both sides. So now we know that e to the negative 6x power is equal to 30. So the way we get rid of e, my natural base, is to use my natural log. So I'm going to take the natural log of both sides. Take, oopsies, the natural log on this side, and I'll take the natural log on this side. So natural log and e cancel each other out. So we're just left with negative 6x over on the left. And the right is just the natural log of 30. So then the last thing you want to do is divide by 6 on both sides to get x by itself. So x will be the natural log of 30 divided by negative 6. So if we put that into our calculator, that's going to give us negative 0.57. So tomorrow we'll practice this, and then we'll start on some word problems to actually apply these to some situations. So you're ready for a whole lot of radioactive decay and bacteria and population and all that sorts of stuff. So it's going to be a great time. I hope you guys have a great day. See you later.